In this lesson, I'm going to discuss the slope of a line, including how to calculate the slope of a line, how to use the slope to compare the steepness of two lines, the slopes of increasing, decreasing, horizontal, and vertical lines, and the slopes of parallel and perpendicular lines. The slope of a line measures how the line is slanted, and it can be computed from knowing 2 points on the line. The symbol used for the slope is m, and the slope is defined to be the vertical change divided by the horizontal change. Sometimes we say that it's rise over run, where rise represents the vertical change and the run represents the horizontal change. And it can be computed by taking the difference between the two y coordinates and dividing that by the difference between the two x coordinates. Notice in the picture below, the two given points are at the ordered pairs -4, -2, and 2, 2. x1 and y1 represent the x and y coordinates of the first point, and x2 and y2 represent the x and y coordinates of the second point. So the slope, m, would equal y2 minus y1 divided by x2 minus x1, which in this case would be 2 minus a -2 divided by 2 minus a -4. You have to be very careful with your signs because sometimes you'll be subtracting a negative number, which is the same as adding. So this would be 2 plus 2, which would be 4 in the numerator, and 2 plus 4, which would be 6 in the denominator. This means that if we start at the point on the left, we'd have to go up 4 and to the right 6 in order to get to the point that's on the right. Now whenever the slope can be reduced, we should do that. So in this case, we could reduce this down to 2/3. Now that we've reduced it, we can see this would be equivalent to going up 2 and to the right 3 2 times in a row. So if we start at the point on the left and we move up 2 and to the right 3, and then we move up 2 again and to the right 3 again, we would get to the point on the right. So reducing the slope breaks a big step into 2 or more smaller steps. We can use this pattern to find many other points on this same line. If we go up 2 and over 3 again, that'll bring us to another point on the line. And if we keep doing it, we'll keep finding other points on the line. Now it's important to understand that there's 4 different cases for slope. A line can either be increasing, decreasing, horizontal, or vertical. Now if a line is increasing, its slope will always be positive. The bigger the positive number is, it means the steeper the line is. So a line with a slope of 3 would be steeper than a line with a slope of 2. So if you're trying to compare two slopes, and both of them are positive numbers, the one with the higher number will always be steeper. Now the second case is when a line is decreasing, its slope is always negative. Now if you're comparing two lines that have negative slopes, the one with the higher absolute value is steeper. For example, a slope of -3 would be steeper than a slope of -2. In this case, the absolute value of -3 is 3, and the absolute value of -2 is 2. And since 3 is the higher absolute value, that indicates the steeper line. Now in the third case of a horizontal line, the slope is always 0. The reason for this is if you pick any two different points on the line and you calculate the slope, which is rise over run, the rise is going to always be 0 because the 2 points have the same y-coordinate. And the run will be some other number. I'll just represent that with some constant k. But regardless of what k is, 0 divided by any other number is always 0. Now that brings us to the last case of a vertical line. Now a vertical line has an undefined slope. Now undefined means you can't get an answer for the slope, so there really is no slope. The reason for this is, again, since m is rise over run, if you pick any 2 points on a vertical line, the difference between the x-coordinates will be 0. So you'll have a 0 as your denominator. And the difference between the 2 y-coordinates will be some other number, which I'll represent with k. But you've probably learned in the past that dividing by 0, meaning 0 in the denominator of a fraction, is undefined. And that's the reason why a vertical line has an undefined slope, because it causes division by 0. Next, I'd like to discuss the slopes of parallel and perpendicular lines. First of all, with parallel lines, since slope measures how a line is slanted, and parallel lines are slanted the same way, you'd probably guess that the slopes of parallel lines are equal, and that is true. Now with perpendicular lines, it's a little more complicated. Obviously, slopes of perpendicular lines will not be equal, since they're not slanted the same way. In fact, as you can see in the picture shown here, one of the lines has a positive slope, the one that's increasing, and the other line has a negative slope. So they can't possibly be the same. Well, what it turns out is for perpendicular lines, the slopes are negative reciprocals of each other. Now you might wonder, what are negative reciprocals? Well, first of all, if the slope of one line is positive, then the slope of the other line has to be negative. So they'll have opposite signs. But they'll also be reciprocals. So if the slope of one line was, for example, 3/4, then the slope of the other line would have to be negative, and also the reciprocal, so meaning the fraction would be flipped. So it would be negative 4/3. So 3/4 and negative 4/3 would be called negative reciprocals. They have opposite signs and they're also reciprocals. And this is how the slopes of perpendicular lines will work. Alright, let's try an example where we're given a certain line and we're asked to draw a line that is perpendicular to the given line. Now the first step would be to find the slope of the given line. In order to do this, we need to locate some ordered pairs that are on the graph. Starting on the left side, it looks like the point -10, -8 is on the graph. It also looks like the point -5, -5 is on the graph. The point 0, -2 is also on the graph. Also, the point 5, 1 is on the graph. And lastly, the point 10, 4 appears to be on the graph. Now that we have these points, we want to try to use the rise over run idea to find the slope of this given line. Let's start at the point on the far left, -10, -8. If we start at that point, it looks like we have to go up 3 and to the right 5 to get to the next point. And from that point, it looks like we need to go up 3 and to the right 5 again to get to the next point. And then again up 3 and to the right 5 and up 3 and to the right 5. So clearly the rise is 3 and the run is 5. Therefore, the slope of the given line is 3/5. And clearly the given line is increasing, so it makes sense that the slope is a positive number, positive 3/5. Now, using what we know about perpendicular lines, a line that's perpendicular to this would have to have a negative slope and also would have to be the reciprocal, 5/3. Therefore, the slope of a perpendicular line would be negative 5/3. Now, when we interpret a negative slope like this, it's simplest to put the negative sign in the numerator of the fraction rather than in front of the fraction. So we can rewrite this as negative 5/3. To interpret this, the negative 5 is the rise, meaning we'd have to go down 5 because down is the negative direction. And the run is 3, meaning we'd still go to the right by 3. So this slope will go down 5 and to the right 3. Now there's many perpendicular lines to the blue line that was given. Since we just need to find any one of them, we can pick any point we want as a starting point. I'm going to use the point -2, 7 as the starting point. I've chosen this arbitrarily. I could have put this point anywhere I wanted. Now, from this point, I want to go down 5 and to the right 3. So I'm going to move down 5 and to the right by 3. And that will bring me to another point on the line. And then I'm going to do that a couple more times. So I'll go down 5 again, and to the right 3, and then down 5 again, and to the right 3. And each time I do that, it brings me to another point on the line. Now once I connect these points, I'll have graphed a line that's perpendicular to the given line.